Welcome to Module 2, Check Sample Measurement and Detector Calibration.
Thermo Scientific Niton analyzers are capable of providing you with very high precision and accuracy. However, in order to maintain this precision and accuracy, you have an important role to fill. Your job is to verify that the instrument is performing properly on a routine basis. To enable you to do this, we supply a certified NIST traceable reference standard with your analyzer. This reference sample will help you verify the instrument is functioning properly.
To follow along, please power up and log into your instrument. You'll want to allow a moment for detector cooling stabilization. When your analyzer is stabilized, you'll want to verify that the instrument is set to the desired analytical mode. From the main menu, simply press the mode icon on the touchscreen. Alternatively, you can use the four-way selection pad to highlight the mode icon and press the clear Enter key. Using the four-way control can help prevent soiling of the touchscreen during field use. When the modes display appears, you will notice that one of the application icons is highlighted. As you can see here, the metals icon is highlighted in blue. Note that your instrument may not have all of the displayed modes installed, so some choices may be grayed out, indicating that they are not selectable.
These additional modes include bulk analysis for standard soils use in environmental and geochemical survey, mining mode and submodes, and consumer goods analysis including test all, metals and minerals, as well as plastics. Many modes can be installed for a wide variety of applications. Your local Thermo Scientific Niton Analyzer's representative can help you with additional application needs.
Select the metals icon to bring up the available metal modes on which this instrument includes standard alloy, electronics alloy, precious metals, and metal coating. Some of the standard alloy subgroups are included but are not normally needed for PMI applications. For normal PMI work, select the standard alloy icon, which will take you to the data entry test screen where you are ready to begin testing. This is also where you will enter data if you choose to do so. You are now ready to verify your instrument's performance with your check sample.
Here we see an example of the certified reference sample for standard alloy use. To make it easy to remove and reinsert the alloy sample, make a small slice across the top of the bag, making sure you replace the sample in the smaller plastic bag when you're finished with it. It's now time to take a quick verification test. However, before we operate the analyzer, we need to discuss a very important subject, radiation safety. Never point the instrument at yourself or someone else. Be sure to read and completely understand the radiation safety section of your user's guide before attempting to operate this device. Additionally, some countries or jurisdictions require that operators receive specific training before they're allowed to use the analyzer. Some jurisdictions also require licensing, permitting, or registration for either the company or the user. If you have any questions with regard to local requirements, please contact your local Thermo Scientific Niton Analyzer's representative.
We are now ready to test the check sample. To do this, you will place the front end of your instrument on your sample. Note the locator markings on either side of the analyzer front end that indicate the vertical location of the measurement window to aid you in positioning the analyzer on the sample. It is very important to note that for radiation safety purposes, you must never hold your hand over the sample.
As we initiate the measurement, note the display, as shown here, indicates the elapsed time. You must keep the trigger pressed during the entire measurement. When the analyzer has positively identified the alloy grade of the check sample, you will hear a beep from the instrument. When you pass the 5-second mark, you will hear a second beep. This indicates that the typical test measurement time for routine PMI sorting of unknown alloys has been reached. For check sample testing, ignore this beep and continue to hold the trigger for approximately 20 seconds. To terminate the reading, simply release the trigger.
Before we look at the results, let's talk about your check sample. Make sure to store this sample in a supplied, resealable plastic bag and keep the surface clean and rust-free. Included with your paperwork are factory measured values for their check sample. Note that your check sample may not necessarily be the exact same lot number as the factory check sample, but it will be the same grade of alloy, a 1.25 chrome half moly certified reference material, or CRM. For example, our CRM has a chromium value of 1.16, whereas the factory CRM value is 1.12. Our CRM molybdenum is 0.48, whereas the factory CRM value is 0.46.
Okay, we're going to review the check sample results, but we're going to give you a little information about the screen display first. Here we see on the top line sample number 11, tested in the all alloy mode. We see our navigation, and tools menu. We see the measurement time, 20.8 seconds. To the right of that is the battery indicator, the grade identification of the sample, 1 1/4 chrome, the quality of match number, 0.0, which we will discuss later, then the element table, the symbols on the left-hand column, the percentage readout in the center column, and the 2 sigma standard deviation, or the precision of measurement, in the right-hand column. The instrument can be configured to show a precision based from 1 to 4 sigma, but is factory set to 2 sigma, which is a 95% confidence level. We will discuss this in more detail in Module 3.
A properly operating instrument will correctly identify the 1 1/4 chrome and half moly grade of the sample and will meet the criteria for the analysis values. Your analyzer should correctly identify the 1 1/4 chrome, half moly, and the chrome should be within plus or minus 20% of your certified value and the moly within plus or minus 15%. You will add and subtract these allowable differences from your check sample certified values.
If either of these values is not within the required tolerance, retest the check sample for another 20 seconds. This will eliminate the possibility that the previous shot was a statistical anomaly. If the result is still outside the expected boundary 2 times in a row, the calibration is not correct. In this case, perform a detector calibration and retest the check sample. Should this not bring the result into the required range, please contact your local Thermo Scientific Niton Analyzer Service Department for assistance.
We've entered the reference sample results into this table. This is from the last measurement. This will allow us to provide an example of the measurement results. We see, for example, the element chrome is certified at 1.11%, whereas our test result is 1.14%. However, when we consider the 20% allowable deviation from certified value, or multiply the 1.11 by 0.2, we get approximately 0.22% allowable deviation. This value is added and subtracted to the certified value, which gives us a measured reading lower limit of 0.89% and an upper limit of 1.33%. Our chrome reading of 1.14 falls within this range.
The moly is certified at 0.48%, which multiplied by 0.15 for the plus or minus 15% allowable tolerance gives us an allowable deviation value of plus or minus 0.07%, establishing the acceptance range for moly from 0.41% to 0.55%, lower and upper limits. Our reading of 0.498% falls within this range. However, we will perform a detector calibration in any case, as it is simply good practice to do so on a daily basis.
I'm going to take you through the detector calibration now. This daily calibration will help prevent minor amounts of electronic drift from affecting your measurement results. Because we're hooked up via our USB cable, we'll perform and show the results on the PC, the personal computer. From the results screen, we select the nav drop-down menu. From the list of options here, we select the main menu and then Utilities. From the Utilities menu, we select Calibrate. From the Calibrate menu, we can select the Calibrate Detector option. This initiates an automated detector calibration update that will take up to several minutes. This depends on the configuration of your instrument. You may want to pause the DVD until your calibration is complete.
It is important that you are careful not to place your instrument near a CRT device, like a TV or a computer monitor, or any other known source of EMF emission during the detector calibration process. You'll also want to avoid any source of loud noise or vibration. We do recommend that you place your instrument in a quiet place so that it is not disturbed during the calibration process.
During the detector calibration, the analyzer will display this screen. At the conclusion of the detector calibration, the analyzer will show the results of the calibration as we see here. A good diagnostic indicator of detector stability is the degree of change in the detector resolution value. We recommend monitoring this value at the conclusion of each detector calibration. If this value goes beyond the plus or minus 20% range of the resolution value when you first took delivery of the analyzer, please contact your nearest Thermo Scientific Niton Analyzer Service Center for assistance.
You'll want to record the values of detector resolution from the calibration that you just performed. This will give you the initial value for future comparison. Let's take a look at the resolution from the detector calibration that we just did. We see it as 167 eV, or electron volts, the standard unit of measurement for detector resolution. 20% of 167 is plus or minus 33 eV. This will give you a lower limit value of 134 eV and an upper limit value of 200 eV. Any computed resolution value outside this range may indicate a problem with the detector. In the unlikely event that this should happen, please contact your nearest Thermo Scientific Niton Analyzers Service Department.
This screen shows the result of the remeasurement of our check sample. As we can see from the results for each element, we are within the boundary conditions that we established previously. If your check sample reads correctly as well, you're now ready to test unknown samples.
This is the end of Module 2. Module 3 will cover the measuring of unknown samples.